This chapter covers introduction, whole numbers, the number line, properties of whole numbers, patterns in whole numbers. The first 10 natural numbers. We know that numbers 1, 2, 3 are called natural numbers if we add 0 to the collection of natural numbers. Now the numbers are 0, 1, 2, 3. These numbers are called whole numbers. The number 0 is the first and the smallest whole numbers. There are infinitely many or uncountable number of whole numbers. All natural numbers are whole numbers. All whole numbers are not natural numbers. For example, 0 is a whole number but it is not a natural number. Addition and multiplication of any two whole number give a whole number. Subtraction and division of any two whole number may or may not give a whole number. The number line is the infinitely long line containing all the whole numbers. The line starts at 0, and any two consecutive whole numbers have the same distance between them. The distance between 3 and 5 is 2 units. Likewise, the distance between 1 and 6 is 5 units. The number on the right is always greater than the number on the left. As number 5 is on the right of the number 2, hence 5 greater than 2. The number on the left of any number is always smaller than that number. As number 3 is on the left of 7, so 3 less than 7. Addition using number line. If we have to add 2 and 5, then start with 2 and make 5 jumps to the right. As our fifth jump is at 7, so the answer is 7. Subtraction on the number line. If we have to subtract 6 from 10, then we have to start from 10 and make 6 jumps to the left. As our sixth jump is at 4, so the answer is 4. The subtraction of 6 from 10 is 10 minus 6 equals 4. Multiplication on the number line. If we have to multiply 3 and 4, start from 0 and skip 3 places to the right 4 times. Division on the number line. If we have to divide 6 by 3, start from 6 and subtract 3 for a number of times till 0 is reached. The number of times 3 is subtracted gives the quotient. Closure property. Two whole numbers are said to be closed if their operation is also the whole number. Whole numbers are closed under addition and also under multiplication as shown in the table below. Whole numbers are not closed under subtraction and division, as shown in the table below. Commutative property. Addition and multiplication are commutative for whole numbers. We can add or multiply two whole numbers order, but the result will be the same. For example, 1 plus 9 equals 10, 9 plus 1 equals 10, 3 into 4 equals 12, 4 inches to 3 equals 12. 2. Subtraction and division of whole numbers is not commutative. 6 minus 3 equals 3, which is not the same as 3 minus 6 equals minus 3. 10 divided by 2 equals 5, which is not the same as 2 divided by 10. Associative property. Addition and multiplication of whole numbers are associative. This means that when we need to add or multiply a few whole numbers, we can choose to group them in any way we like while performing the operation. For example, 5 plus 6 plus 4 equals 15 equals 5 plus 6 plus 4, 2 times 3 into 4 equals 24 equals 2 into 3 into 4. 2. Subtraction and division of whole numbers are not associative. Distributivity of multiplication over addition. This property says that if we have three whole numbers x, y and z, then x into y plus z equals z plus xz. For example, 4 into 5 plus 3 can be written as 4 into 5 plus 4 into 3 here. 4 into 5 plus 3 equals 52. Also, 4 into 5 plus 4 into 3 equals 20 plus 32 equals 52. If we add 0 to any whole number, the result will be the same number only. So 0 is the additive identity of whole numbers. This clearly shows that if we add 0 apples to 2 apples, we get the 2 apples only. Identity for multiplication. If we multiply 1 to any whole number, the result will be the same whole number. So 1 is the multiplicative identity of whole numbers. Patterns. A list of numbers that follow a certain sequence. Every number can be arranged as a line. Some whole numbers can be expressed as squares. Some whole numbers can be expressed as rectangles. Some numbers can also be arranged as triangles. Use of patterns. Patterns can be used to simplify the process as shown below. 123 plus 9 equals 123 plus 10 minus 1 equals 133 minus 1 equals 132. 123 plus 99 equals 123 plus 100 minus 1 equals 223 minus 1 equals 222. 83 times 9 equals 83 times 10 minus 1 equals 830 minus 83 equals 747. 83 times 99 equals 83 times 100 minus 1 equals 8,300 minus 83 equals 8,217.